Hi everyone, here is my Module 2 Erosion Bottles project. So for the ask part of the design process, what happens to unprotected soil when it rains, and how do plants help soil survive? For the imagine part of the design process, test the issue of what happens to unprotected soil when it rains, test how exactly plants help soil survive, and use the erosion bottle to test these questions. For the ask and the imagine part, I really looked into the soil simulations to kind of test a hypothesis as to which I think was going to do better. So I'm going to move on to the next step, the plan part. So I'm going to need 3 bottles to test these questions, one with just soil, one with soil and mulch, and one with soil and grass. And I got these ideas from that simulation model to test just how just soil would do on its own, how soil and mulch would do, and how would soil and grass do. My hypothesis is that the soil is going to produce the most runoff water and erode most of the soil. The one with the soil and the mulch is going to produce kind of in the middle. It's going to have less erosion of the soil because of the mulch protecting it. And then the last bottle, the one with soil and grass, is going to have the best where it's not the most eroded from the soil. The soil isn't eroding the most because of the grass protecting it. So here was my create process. So the first bottle, again, I just had soil in it. Second bottle had soil and mulch. And the third bottle, I had tried to grow grass seed in it, but unfortunately it did not end up working out for me. So I'll talk more about that in the improved part. But so here I have some videos. I'm just going to kind of skip through. If you would like to, I'll post my PowerPoint slides and you can kind of watch those videos then. Here is the end result. So the first one with just the soil had the most erosion in the water. The second one, it was a little better. Still, the soil eroded, but not as badly as the first one. And then the last one, the clearest water, the less the soil that eroded. So here is my improved part. To improve this project, I could add more things to the soil and mulch bottle, things like leaves and sticks, and I thought the runoff water from this bottle was almost the same color as the just soil bottle, so I thought adding more things in to protect the soil might help to improve that. And then my last part here, I could also spend more time growing grass in another bottle and compare this bottle to the dug up grass bottle. The dug up grass bottle did have clear water. I'll go back to that one. But I still think if I would have actually grown the grass, I think the roots and the grown grass would have helped to protect the soil much better. Here is the STEM practices chart. So for science, I had ask questions, develop and use models, plan and carry out investigations, obtain, evaluate, and communicate information. The engineering side, I pretty much had the same thing as science except for ask questions highlighted. In this project, we had to ask questions about what was going to happen with our erosion bottles. We had to develop and use the models of the erosion bottles, modeling the soil and when it rains. We had to plan and carry out the investigations with the erosion bottles, and then we had to obtain, evaluate, and communicate information. For the technology side, I needed to use the role of technology with the simulation, the soil simulations. And then for mathematics, I had to make sense of problems and persevere in solving them. Just like when I couldn't grow the grass, I had to come up with another solution. And then lastly, here is my NGSS standard. Ask questions, make observations, and gather information about a situation people might want to change to define a simple problem that can be solved through the development of a new or improved object or tool. Thank you so much for watching.